All right, let's look at the homework 3.7, problem number 2. All right, so we have this function, y equals x plus 6 over x, and we want to find x-intercept and the y-intercept. So let's do that. All right, so to find x-intercept, we're going to set y equals 0. All right, so set y equals 0. So I'm going to just actually go ahead and do that. All right, 0 is equal to x plus 6 over x. All right, so we just need to make sure that the numerator is equal to 0. So we know that x plus 6 must be equal to 0. All right. Then we know that we can just subtract 6 from both sides. So you have x is equal to negative 6. All right, and let's go ahead and find the y-intercept as well. So you have y-intercept. So we're going to set x equal to 0, but unfortunately, right, y of 0 is undefined, right, because denominator becomes 0. So this guy is undefined. Right, so which means that there is no y-intercept. So we can just say no y-intercept. All right, so let's type in the answer. Nope, that's not it. Oops, that was the wrong one. All right, so x-intercept is negative 6, comma 0. And the y-intercept, we didn't find one, so it does not exist. All right, let's check the answer. All right, I came back and looks like we got x and y intercepts correctly. All right, so let's find the local maximum and the local minimum. All right, so let's do that. All right, so we need to take the derivative. Before we take the derivative, I'm going to actually rewrite this. All right, so x divided by x is 1. All right, then you have plus 6, and 1 over x is x to the negative 1. So this is exactly the same function, right? So if you take the derivative, so y prime is going to be, right, derivative of 1 is 0, and derivative of this guy would be negative 6 x to the, subtract 1 from the power, so it's a negative 2, which is just negative 6 over x squared, right? So you can see that this is actually never equal to 0, which means that there is no critical number, right? So there's no critical number to test out, and so we don't have, in this case, the local maximum or local minimum. So it's going to be does not exist for local maximum, and also local minimum does not exist. All right, let's check the answer. All right, I came back and that looks like we got the local maximum and the local minimum correctly because we don't have them. All right, how about the point of inflection? All right, so inflection point, so we're going to take another derivative. So you have a y double prime, right, is equal to negative 6 times negative 2 is positive 12, x to the negative 3 power. So this is equal to 12 over x cubed, right? So you can see that here again, this is never 0, right? And it's undefined at the x equals 0, but the 0 is not included in the domain. So there will be no inflection point either, right? So it's going to be does not exist, right? Let's check the answer. All right, I came back and let's see, we got this one correctly. So there's no inflection points, all right? So it's not very interesting. We have a whole bunch of does not exist, and hopefully we have asymptotes. All right, horizontal asymptote, all right? So look at the degree on top. Degree on top is 1, and the degree on the bottom is 1. So when you have a tie, you look at the leading coefficient, which is 1 on top, and leading coefficient of the bottom, which is another 1 on top. So y equals 1 over 1, which is just going to be 1. So y equals 1 is the horizontal asymptote. All right, about the vertical asymptote, all right, so so no common factor on top and bottom, and since it's a rational function, we set the denominator equal to 0. So x equals 0 is vertical asymptote. All right, so let's check the answers. All right, I came back and looks like we got the asymptotes correctly, and we can just pick the correct picture. All right, so let's see. We have to make sure that let's see, you have a horizontal asymptote is y equals 1, and vertical asymptote is 0. All right, so it looks like this one follows that. So there's y equals 1 and x equals 0, and second one follow that. And here, horizontal asymptote seems to be negative here, so we can eliminate number 3. And number 4, same reason, we can eliminate it seems to have a wrong horizontal asymptote. Alright, so it's going to be between this one and that one. Alright, then we know that the X-intercept is negative 6, 0. So negative 6, 0, here, negative 6, 0, there's no negative 6, 0 intercept, X-intercept there. So this is the correct picture. Alright, let's check the answer. All right, I came back and looks like we got the correct picture as well. All right, that's it. I hope that this was clear.